Good evening, everybody. Wonderful audience with a lot of people. I mean, I didn't expect this much and this many people to be attentive for this very basic and normal topic. Though it might sound very boring, but at least it's very effective for people who are working in the cab, at least. Right? So, rubber seals in the cab. Why do we need it? We- Yeah, let's see the fundamentals and operating demand. Like, what is the demand for the people who are operating? Understanding the rigorous operational environment of Indian Railways and why elastomer sealing systems are mission critical. Like everyone will be more well versed than me with respect to the loco. So how the loco works, where the loco works, is more than aware. Like right from the Kanyakumari to Jammu, it runs throughout the Indian pan with even in a single trip, the temperature varies drastically more than 20 to 30 degrees. So whoever is driving inside the camp should not feel, at least should feel the bare minimum what is outside. So be it shower, be it rain, or be it very dusty environment, or with the heat, whoever is driving the cab should not feel the heat. I mean, they should not be like the circumstances or the environment should not affect in their concentration because a small lapse in their concentration or whatever it is could lead to a potential danger. In simple stuff, it's for the crew convenience. Like Indian locomotives travels through deserts, Himalayan foothills with a lot of UV degradation. I mean, UV exposure, temperature fluctuations, and even the vibrations, everything. So if we don't have a proper seal that properly sealing the cabin, wind might get enter inside. Temperatures outside will be soaring high. Like if the AC, we are what is providing, like especially in WG12 or it's HVAC and WG, all the locals, even WG7, we are equipped with AC over there. So if doors and the cabs feel AC will not be effective at all. So at least for the crew convenience, or especially for the crew convenience, the sealing is a very important parameter actually. Yeah, basic recurrence acoustic insulation. Yeah, everyone will be aware. People who have worked in WB before and WG7 will know how this it's difficult for someone to sit inside when there is a blower motor and everything is kept on. Like there will be a lot of noise. At least in cab one side will feel lesser because in cab two with more of these relay panels and everything, there is a possibility that the crew will be finding it more difficult. So it's just from the inside. Now what like from outside as well. If you are like running, the crew is running through some very harsh environment where like its the decibel level is more than 80, 90, that is beyond the tolerance level of the human, and obviously it's going to affect. So a closed, airtight cabin will always help the crew in like alienative from whatever it is in outside, including the acoustic or water ingress for that matter. Rain pouring inside is no one will be liking, be it a home or be it in the loco itself. And toxic fume exclusions is that if some smoke outside and if it's for the diesel engine, maybe the diesel stuff itself might come inside. So to prevent all this stuff, sealing is of paramount importance. Key sealing zones in locomotive cabs. So where are those rubber seals that actually come in place? Windscreens and glazing gaskets. Like glazing gaskets obviously is for the windshields only. Uh, in the sense, windshield can be placed by two methods. One is that normal rubber beading, the key beading stuff, whatever the profile with UPH, whatever it is, structural profile beading. And the other one is the glazing type where you use more of a PU type sealant and everything that's more rigid. It's less prone to those cracks or whatever it is. Glazing will be looking good as well. So whatever it is, the sealing should be proper. Like say eschewed EPDM profiles, laminated safety glasses, secure with monsoon sealing, shock absorption. Glazing is more helpful in shock absorption than the conventional key beadings, but conventional key beadings it's more maintenance friendly in the aspect like it's like if you want to change the glass or something, it's more easier rather than this glazing type. That's more in the maintenance aspect, but at least sealing should be proper. Like this is a cab entry, like doors. In WG12 and all, there is a minimal outside interference. Apart from the windshield, there is all like a door glass and all, whatever I see, it's very small. But in conventional logos, we see that like a triangular glass will be there. There is a shutter glass. There is a, I mean, metallic shutter plus glass shutter, everything. There are a lot of openings for this conventional logos. So there and all, we'll use different types of rubber beading. Those are different profiles of beadings that we use. Most commonly, it will be U and other beadings as well. Uh, it's readable. I mean, it's easy understandable as well. And apart from the ceilings, obviously, like a, mm, mm, I'm talking about like bigger stuff like doors and windows. There are some minute aspects like a grommets, AC, decks, where also the ceiling should be proper. And obviously, if the ceiling is not proper in the roof, I mean, air, water will be coming over here. So break wall diaphragms, AC, duct gaskets, cable grommets. These are the other steps where the ceiling we use rubber items. Material science and specification. Like say what sort of material that we actually use for sealing. Like this is the gold standard for external weather seals and windscreens are EPDM, ethylene, propylene, diene, monomer. This has a characteristic that actually suits our railway purpose, which uh, like a train being working in harsh environments that is exposed to I mean UV sunlight and as well as rain, and apart from that it goes to various places where they are even chemically exposed. So EPDM is a sort of thing that used, I mean, mainly used in windshields and all. It helps withstand these things so that the life is prolonged. At least once we provide it, hopefully we'll have to replace only in the next AOH. And the lesser thing is the neoprene or chloropene rubber, even sponge, even in conventional locomotives for the cab doors also we use sponge rubber. With the show hardness around like 45 to 60 in that range, we use sponge rubber as well because it helps in cushioning. In the sense if you are opening the door, that it should be crushing somewhere so that it's properly sealed. Otherwise, if it's a more of a rigid thing, obviously with the misalignment there will be a small gaps through which anything could percolate. So APDM and sponge rubbers will help in more of way of sealing it. A modern ergonomic integration. This is the pressurized cabin structure in WG12, WG9D, whatever it is you're seeing the advantage of this WG12 especially is that it creates a positive pressure within the cab with the help of these sealings. I mean, at least this, if it's not properly sealed, we will not be able to create a positive pressure within the cab. The reason for the positive pressure is that obviously in everything it goes from higher pressure to lower. So the possibility of what is dust or like a air or for that matter water also entering into the cabin will be lesser if we have a positive pressure within the cab because obviously it will go from here outside, I mean from inside to outside. So to create that environment, this sealing is an important parameter. And that is the reason also it's like a more robust if you see WG12 and all. Like they say HVAC, I mean heat, ventilation, AC, that's what it stands for, I guess. All those WG12s are with the concept of HVACs. RDSO standard quality compliance, like a windshield, what we call lookout glasses, it's obviously of EPD, so that it's UV and ozone resistant. Cab doors, even previous logos and all we use EPDM, but in some areas we still use those sponge rubbers with a better shore hardness. Then gaskets and all those grommets, obviously it has to be non-inflammable. I mean, non-flammable. Maintenance, failure analysis, and future outlook. Like, how do we, hello, what causes the failures in the seal? It is thermal hardening, mechanical abrasion, and chemical degradation. Thermal hardening means like any rubber that is exposed to a harsh environment, is a possibility of cracking. Once it cracks, it might like extend throughout, and it will look, the entire thing would have been peeled off for like what it doesn't serve the purpose. Mechanical abrasion, vibrations, everything, and if it's repeatedly used or if it's like forced, it can tear. And chemical degradation, like if it's met with some chemical substance, even for that matter, paint or whatever it is, sometimes also even applying paint in a gasket or rubber will cause it to harden. A hardened thing will be cracking easily. Maintenance protocols and overalls. Cap seals are to be thoroughly inspected. Whenever we see that if there is a slight cut or if it's hardened, you should replace it. Especially in AOH, we do replace all those rubbers. And periodic maintenance, there are certain sprays that we can spray upon so that it will give more longevity. Yeah, yeah, that's it. Thank you.